Hi guys, welcome to my channel. Today we are going to be looking at Physics Mechanics Practical 2023. I know it is something that a lot of us have been waiting for, but like I always do, I'm not going to go directly and just show you the experiment and setup. I need to take you through everything about the experiment. As a teacher, most times when Waec come with their manual, we always rush down to pass questions to see if we are going to find previous experiments that has the same apparatus as what they asked us to provide. That is totally wrong. For example, this year, a lot of teachers find it difficult because this particular questions is not there in the past question, that's previous questions is not there at all. But what exactly you need to do as a teacher whenever you have a manual? The first thing you want to understand and do is to know the experiment that particular manual is pointing towards. When I say experiment, I mean knowing what examiner wants you to determine. For example, do they want you to prove Hooke's law? Do they want you to prove the principle of moment? You don't want to prove this or that. That is the first thing that you need to work on as a teacher, even a student. Now, looking at this experiment, absolutely, if you look at the whole of the things Waec asks us to produce, they are all pointing down to spring mass system. Spring mass system. That is, you are to determine the spring constant. That's what the experiment is all about. So, having know this, how are we now going to set up the apparatus? I'm going to start from there. Then I'm going to take you down to how to carry out the experiment. Then, from how to carry out the experiment, I'll take you down to how to manipulate your reading. That is, if maybe because of time or something, you can't carry out the experiment and you want to have accurate results, I'm going to show you how to go about it. So without any further ado, let's get started. Now, what is the question that we have here now? So this is the setup now. This is the setup. So can you see what the diagram look like now? It's very important you look at this very well, because when you setting up your apparatus, it must look like this. We have a weighted stand. We have the helical spring, we have the meter rule, this is the pivot, and this is the mass labeled Q and the mass labeled P. Now, this is how your setup should look when you finish setting it up. It's very important you look at this. Now, you can have different setup, absolutely, for this same experiment. But I decided to start with this. If time permits us, and I have the time, I'll create another video showing you another setup and another procedure. Now, this procedure that you have here, it's something I come up with. It's not something set by examiner. So it might not be 100% standard, but it gives you an idea of what you are to do and how to go about it. It's very important you know all of these things. Very, very important. And I've also helped you with the whole of the equations that you might probably need to get familiar with under this same experiment, that is mass spring system. All equations here, they are meant for this particular experiment. And the major one that you need to focus on as far as this experiment is concerned is the one of T equal 2 pi the square root of M over K. That is what the mathematical statement of this experiment. And this is what we are going to be using to determine our reading if we choose not to carry out the experiment. Am I making sense now? Now, this is the mass, this is the spring constant K, and what again? We have 2 pi and we have the period. Now, I want you to understand something as a teacher. Examiner will come that very day and give you a manual to fill. What are the things that you might probably want to fill under this experiment 1, the mass of your meter rule. Because the mass of the meter rule is what? It's added to the mass that you are putting on your spring. Am I making sense now? The mass of the meter rule add to what? The mass you are putting on the string. For that reason, examiner will ask you to provide the value for the mass of your meter rule. And secondly, examiner will ask you to provide the spring constant of the spring that you are using. How do you determine all of this? Let's start from there. Let's say you want to determine the mass of your meter rule. You are going to determine the mass of your meter rule using the principle of moment. The first thing is that place your meter rule on the knife edge. When you place your meter rule on the knife edge, make sure it's balanced horizontally. Make sure it's balanced horizontally and note the point of balance. Like now, this particular one now, it's balanced at 49.8. You can see the balance point here. 49.8. It doesn't balance at 50. Am I making sense now? Normally, for your meter rule, it's supposed to balance at 50. But because of factory error, it doesn't balance at 50. So it's fine. Note where it's balanced, which is what? 49.8 centimeters. So, okay, I think I have a pen here. So that's the first thing you are going to do. You note the balancing point down. So you write it as G. That is, your center of gravity is 49.8 centimeters for the meter rule that you are using. After you note that, you pick different masses. You can decide to pick the one of 100 gram, like I will do. I'm picking 100 gram and 20 gram. Am I making sense now? 100 gram and 20 gram. So what am I going to do? I'm going to apply what? Rope, that is a string, to attach this 20 gram. I will attach it at one end of the meter rule like this. You can put it at any value of your choice. Then pick the 100 gram. I think you need to move closer so that they can see it clearly. So when you add this now, connect that of 100 gram just like we did for that of the 20 gram. I'm using 100 gram and 20 gram. You can decide to use 100 gram and 50 gram. You can decide to use 50 gram and 20 gram. It is totally your choice. So you need to try as much as you can to let this firm so that it's not going to disturb you. Then suspend it at the other end of the meter rule. So it's touching ground. So let me reduce the length of the rope. So I think it's fine now. So you can decide to reduce the length of the rope, or you can elevate your, what's it called? Elevate your knife edge, just like I will do now. So I'm picking my robots to elevate my knife edge. So you can see now. So if you look at it now, I'm putting my own 100 gram. I put it on 12 centimeter, and I put my 20 gram, I put it on 88. Are you getting it now? So I start adjusting this meter rule until it's balanced again. So I start adjusting it until it balances. So I think you help me to close those windows. The breeze is disturbing. And that's to tell you that you need to avoid all the things that can affect your ruler from balancing. Am I making sense now? So you close the window to affect or to avoid air coming from the both ends of the openings. Is that okay now? So I will adjust this now until it's balanced horizontally. So when you look at this now, this has balanced horizontally now. Am I making sense now? So come and look at the balancing points. It balanced at where? 37. Can you see? So this balancing point at 37. Now look at what you are going to do now. You now draw your meter rule. You are drawing your setup now. So this is 100 gram. That is the mass that I have here. Can you say this mass 100 gram? This distance from here to this place is 12 centimeter. Can you see? And then my pi volts is balanced at where? 37. So that means from here to where I have my pi volt is 37 centimeter. Are you following? Then this one, the 20 gram mass is at 88 centimeter. Are you seeing it now? Now, because this is a uniform body, for a uniform body, the mass is always at where? At the center. So the mass is going to be at the center of gravity of this one, which is where the mass of this ruler is going to be from here to this place. That will be 49.8 centimeter. I believe you get this right now. So let me get my calculator because we need to start calculation now. So the first thing is to know the distance between here and here. And since from here to this place is 37 centimeter, we say 37 minus 12. 37 minus 12 will give you 25. So this is 25 centimeter. Are you making sense now? And this is the mass of the meter that you are looking for. What's the distance from here to this place? You have 49.8 minus the distance from here to this place is what? 49.8. So you have to subtract 37 from it, minus 37. So that will give you 12.8. Can you see that? And this one is 88. From here to this place is going to be what? 88 minus 37. And we have this to be 51. From here to this point is 51 centimeter. I hope it's clear now. Alright? So if that should be the case now, we can now take what? The moment. So taking moment about the pi volt, we are going to add what? 100 multiplied by 25 to equal to M, because this one will go like this one will also go like this, and this will go like this. So we have what? M times 12.8 plus 20 multiplied by 51. So this one will give us 2,500 equal 12.8 M plus 20 multiplied by 50. That's 1,020 if I'm not mistaken. Yeah, so 12.8 M is equal to 2,500 minus 1020. So 2,500 minus 1020, that will give us 1,480. So the mass M of the meter ring is going to be 1,480 divided by 12.8. So that gives us 115.625. So we are referring to one decimal place, 115.6 gram. So that's the mass of your meter ring now. Is that taken? So that's how you determine the mass of your meter ring. Because examiner will ask you to provide this, and stop calling your colleague to ask, because your mass is not going to be the same thing. I hope we are making sense. Alright, so if that should be the case, what's the next thing that you need to determine, which is the spring constant that examiner will ask you to provide? How do you determine your spring constant? That is also easy. The spring you are about to use, make sure you hang it to where you have your Waec stand. So when you put this on your Waec stand, pick your mass. You can use any mass. You can use the same 100 gram mass, or you use any other one of your choice. So I'm going to be using the 100 gram. Okay, so let me attach it back to the string. Okay, so I have this. So let me just attach it back so that I can determine the value for my spring constant. So I want to know the value for the spring constant right now. So I'm going to get my stopwatch. Okay, so let me get my stopwatch. I think I have it here. Alright. So there are different types of stopwatch. So I would like to show you that. So this is 1 and this is 1. So as a student, if you are using this one, when you want to start, you look at this short one, look at this long one. So this long one is to reset. Can you see? This one is to reset, this one is to start. You can see it has started moving. Now if you want to stop it, you pull this one up. So then when you want to reset again, you pull this. Then if it is this one that you are using, once you click like this, bam, it started reading. When you click again, it stops. When you click again, it resets. I hope you understand this now. So that's awesome. Now I want to know the spring constant here, and I'm going to count 20 oscillation. Am I making sense now? So I'm going to start by counting 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So when you look at this now, my time stop at 15. So I have what? 15 seconds. So the time for the 20 auxiliation. Now watch. The time for the 20 auxiliation is 15 seconds. You can decide to do this twice to repeat the mean value to avoid error. Am I making sense now? So T is what? 15 seconds, and the number of auxiliation is what? Is 20. So all I'm going to do to get my period is going to be 15 divided by 20. That is the time that takes for that auxiliation divided by the number of auxiliation. So 15 divided by 20 will give us 0.75. Am I making sense? So if you have 0.75, what's the next thing to do? The next thing is to come down to this equation, 2 pi the square root of m all over k. So our period is 0.75 equal to multiplied by pi, the square root of what is the mass that I use here. The mass I use here is 100. Convert this to kilogram, that will be 0.1. So I have 0.1 all over k. Square both sides to remove this square. So 0.75 square, 0.75 square, that will give us 0.5625 equal 4 times pi square multiplied by 0.1 all over k. So your k is equal to 4 pi square multiplied by 0.1 all over 0.5625. So when you press the calculator for the value of this, I have 7.02 Newton per meter. So this is my spring constant right now. So I'm going to add this as my report. So my center of gravity is 49.8 centimeter. The mass of my meter row is 115.6 gram, and my spring constant is 7.02 Newton per meter. So these are the three things that are very important. And when we start manipulating this experiment, we are going to see how to go about using all these values. Am I making sense now? Alright, so if that should be the case now, let's get started by setting up the apparatus. So as a student, you need to first of all check the diagram that you have. I get to it now, and set up your experiment, that is set up your apparatus to look like this. So when you look at this now, we have retort stand. This is a retort stand. Then we have what? A spring, that is the helical spring. I have it there. Can you see? I have it there now. So what's the next thing I have in my diagram? I have my meter row. So here is my meter row. And looking at this meter row right here, what I'm going to do is that I'm going to get a string. So let me make use of this one. So attach this string to this. I see it now. Then put your meter row. So when you are doing that, make sure it is firm. It's very important to let it firm so that you are going to avoid trouble. So you can reduce the height of this. So can you see, but don't let it come down too much also. So this is fine. So you attach this. Then pick your pivots, just like you can see in the diagram. You pick your pivots and you have it here. So examiner will tell you the point at which you should put your knife edge or whatever you want you to do with it. So but if you look at this now, this is now horizontally balanced, kind of. Okay, so you have to make sure that everything is upright. Can you see now? Okay, so I will adjust this to start at 10 centimeter. Can you see? And this one, okay, I think I need to adjust this a bit. So let me just shift it here like this. Okay, so let me put this one at the point of 90 also. So this is 90 and this is what? 10. Can you see now? So make sure it's stable like this. Can you see? So what's the next thing? The next thing is that you find point P. Can you see? This is the mass level P. we are asked to put it at the center of gravity. Mind you, examiner might decide that you should put it on another value other than the center of gravity of this word of this meter rule. But for the sake of what I predict, let us put it at that center of gravity. So I don't want you to cram anything here. I want you to understand virtually everything so that your exam can go with ease, even when the question is not exactly like what you see. So I'll put it through this place. Make sure the rope is not too long, because if the rope is too long, it's going to give you problem when you're carrying out the experiment. So once it gets to the center of gravity, you stop. Remember, we determined this one to be 49.8. Yeah. So I'll put this back. So we have the what is it called? The concealed mass P, we have it at 49.8. Mind you, we know as a teacher, you know the value of this. It's only a student that did not know. And if there is a student looking at this, the concealed value for P is 100 gram. You are going to see the usefulness of it as we move on now. So we take the second one, which is 20 gram, mark Q. This one is labeled what? Q. You might not know the value, but the value is what? 20 gram. Your teacher will, and I'm telling you also. So pick your string again. Make sure it's not thin, so that it's not just going to cut. Then you do this. Alright? So you have this now. Then put it here. Make sure you hold it around this so that it's not going to pull off. Can you see? So take it through the side again. And let this one be a bit closer to this side. So, can you see? So let me put this one on 20. So that's 10 centimeters, 10 centimeters. So I'm putting it on 20. So examiner can give you other question than this. So when you look at this now, look at the setup. Can you see the setup now? Look at the diagram. Look at the fulcrum, look at the fulcrum here. Look at retort stand, look at retort stand. This is the spring, this is the spring. These are the two labeled mass. Can you see them there? Absolutely. When you now have what? A good setup like this that looks like the diagram given to you, then you are convinced that you are about to do the right thing. So, where's the next thing? Let's read the procedure. So, the procedure says that displace the spring from its equilibrium position and what? Release it. Start the stopwatch as soon as you release the spring. Am I making sense now? So we have this right here. So the experiment says we should suspend this one to oscillation. So if I press this down like this and I release it, you can see this has started oscillating. Am I making sense now? So let's see how we're going to go about the practical now. So we are asked to add a mass of 20 gram, add a mass of 20 gram to the mass labeled Q. This is the mass labeled Q, and we are asked to add another 20 gram mass to it, which is what we are starting with. So as a student, when you are about adding the mass, get a rough sheet. Can you say, get a rough sheet like this, write down mass of 20 gram. So when the mass is 20 gram, what will happen? You can cut the cord. So when the mass is 20 gram, put this. Can you see now? So you pick your stopwatch. I see this now. Pick your stopwatch. Make sure it's at 0. Then you just start count 20 oscillation. Examiner can say 50. Examiner can say 10. But I'm using 20 oscillation. So let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Alright, so I'm stopping at 20 and I have my result to be 24.5. So this is 24.5. I have my time to be 24.5. So just write that down. And let's move on with the experiment. You can see what I took down, my mass and my time. So what else again? The question now says, evaluate capital T, and what? T square and T square. So how do I get my capital T? My capital T is given as the time taken divided by the number of oxidation. So since the time taken is 24.5, I'm going to add what? 24.5 divided by 20. So if I have that, I'll be adding what? 1.225. 1.225. Then square this value. We have what? I squared twice. 1.225 square. So I have 1.501. Are you seeing it now? So we move to the next one. They said repeat the procedure for 4 other values of M. Repeat the procedure for 4 other values of M. So what are the 4 other values of M? 40 gram. So to increase this to 40 gram, I will add another 20 gram. So that makes it what? 40 gram. Are you getting this now? Remember, examiner assume that you don't know the value of Q. Are you getting it now? So when you add another 20, you pick up your stopwatch again, and then so it's already touching this place now. So there's need for you to reduce this length. Alright? So let me just reduce the length of this rope so that it's not going to be touching the workbench. Because if it's touched the workbench, then my reading will be kind of different. So you can see what I have now. So let me leave the mass back. Alright, so let's start again. 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, I'm not going to use this reading. Do you know why? The reason why I'm not going to use this reading is because I'm not looking at this. I'm just counting the same way I count the other time. So please avoid it. So let's restart. So I'll come down here now. So 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So can you see now? So I have what? I have that when the mass is 40 gram, my time T is 25.30. Yeah, 25.30. Then I have my capital T and my T square. So I can be doing that later because of time. So what's the next value? The next value say 50 gram. So I will add 10 gram to this. You see now it has become what? 50. So I'll start. We'll start the stopwatch. 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's another mistake here again. If you observe, my to and fro is not correct. You need to note all of these things. It's very important. I deliberately commit all these mistakes so that you are going to avoid it. I'm not doing it like a computer, something that I've done before, and I'm just putting down the video. No. Is that okay now? So now, let's restart all over again. So please note very well, when it comes down, that is toe. Before you count 1, make sure it has come up back. That is full. Is that okay now? 1 toe and full, just make one observation. Please note. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Alright, so I have here, when the mass is 50 gram, I have my time to be 26.7. So my T, I'm going to do that later. Okay, so let's do the next one. So the next one is what? 60 gram. So I'll add another 10 to it. So when I add another 10 to it, I'll repeat the same thing. And to save time, because the person reading the camera is going out. So this is how you're just going to go about what? About your reading. So just get this. And how do you know what to tabulate? All these things you measure and evaluate, they are what you are going to tabulate. So for better understanding, you can see my table here. So this is the serial number, the numbers of time you repeat the experiment. This is the mass in gram. This time is in seconds. Then for your capital T, T all over N, it should also be in seconds. For T square, it should be in seconds square. Now, I've always been saying this for students. Whatever mass, whatever value you are given in the question, like now, you are given mass in the question, you are given mass of 20 gram. Make sure it is in one decimal place. So we have the one of 40, it should be 40.0. We have 50, it should be 50.0. 60.0, 70.0. Don't shade, please. Whenever you are drawing your table, don't do what? Don't shade, because if you shade in your table, that is minus 5 marks. If I'm correct, are you getting it now? You are using mark when you shade, so don't shade. Make sure you have done your rough work here and you are transferring the value into this place. Then your time T, you have what? 24.5. So because you are the one that picked this reading from your stopwatch, put it in 2 decimal place. So this one that is what? 24.5. You write it as 24.50. This one that is what? 25.30. This one is what? 26.70. And so on like that. Then for this value here that you evaluate is your calculator, you can either put it in first significant figure or you put it in 3 decimal place. Am I making sense now? Either first significant figure or 3 decimal places. For example, this one is 1.501. You see, it's in first significant figure or 3 decimal places. And that is how you are going to do for every other values on this table. Also, when you look for your T-square, it should also be what? First significant figure or 3 decimal places. I hope you understand this now. So that is how you go about your table. Now, the last part of the practical that we are going to now consider now is when we want to manipulate. How do we manipulate our reading? So that's so simple. Let's see how it goes. I'm going to take you through it for, I'll do like 2. Am I making sense now? And then you can finish it up yourself. So remember that we have been able to determine the following: the center of gravity, the mass of the meter ring, and the spin constant. Alright, so since you are able to know this now, you can now what? You can manipulate. So T is equal to 2 pi, the square root of M all over what? All over K. That is the formula. I get it now, the theoretical formula for this experiment. Now I want to manipulate my reading. So I need to get I'm giving mass, I need to get my time, I need to get my capital T and my T square. So that's how I'm going to get it. Remember, you have mass P that you don't know. Remember, it is 20 gram. You have mass P that you don't know. Remember, it is 100 gram. I'm telling you now, your teacher knows if you don't know. Alright? So if you have this now, then the mass of the meter ring, you have it. I've determined mine, and mine is what? 115.6 gram. So as a teacher that wants your student to manipulate, you must give them all this value. It's very important. So add all these ones together. What do you have? When you add them together, 20 plus 100 plus 115.6, you have what? 235.6 gram. Are you seeing this now? So what the examiner say, when the mass is 20 gram, if the examiner say the mass is what? 20 gram, your own actual mass that you're going to use here is not going to be 20. Add 20 to this one. So it means 235.6 gram plus 20. You are going to have what? 255.6. So this 255.6 gram, convert it to kilogram by dividing it by 1000. You are going to have what? So you are going to have 0.2556. That's what you are going to have as your mass. So put it into this equation. Put it into this equation. You have your T to equal to 2 pi. The square root of the mass is what? 0.2556. Please don't approximate at this point. If you get your final answer before you approximate, divided by my speed constant. My speed constant is determined as what? 7.02 Newton per meter. So I'll put it here. 7.02 Newton per meter. So what am I going to do next? I'll just say this value divided by this, divided by 7.02. That will give me what? Is 0 points. Okay, so I will have that my T is equal to 2 multiplied by this value here. So we'll take the square root of this answer. So square root of answer, you have this. So don't approximate and don't write it out. Just say multiply by 2, multiply by pi. For you to get your pi on your calculator, press shift and press what? Expand. Are you seeing it now? So you see, we have our what? We have our period to be 1.1989. So write it down. Your period is 1.1989 to 4 decimal places. Are you seeing this now? Okay. So what's the next thing to do? The next thing to do is to determine your small t. For you to know your small t, what are we going to do? You are going to multiply this one, this value that you have here, multiply it by 20, because capital T is equal to small t over n, and n is what? 20. That's the number of observation. When you cross multiply, you have small t to equal to capital T times n, then that will become this value that you have here multiplied by 20. Don't use this one. You can see I'm using the exact value of the calculator without approximation. Multiplied by 20, you have what? 23.978. So write it to 2 decimal places. 23.98. Can you see now? So you've gotten your small t. T square, you can get it from here. 1.1989 square. So you have 1.4374. Are you seeing it now? Remember, this has to be in 3 decimal places. So you can now rewrite it. 20 gram. When you are putting it on your table, 20 gram, 23.98. And this one is going to be 1.199. And this one is going to be 1.437. Can you see that now? Now let's compare this value with what we have when we carry out the experiment. Okay, so when we carry out the experiment, 20 gram gave us what? 24.50. Have you? That's what 20 gram gave us. So when you look at this now, we have what? 23.98. It's not really far from each other. They are approximately equal. To the nearest whole number, so no. To the nearest whole number, this one is going to be what? 25. And this one is going to be what? 24. So it's still a line. Am I making sense now? So there's just a slight what? Difference. Why? Because as human being, when you are counting, you are bound to make a mistake. Is that okay now? So this is not too far from each other. Do you get that clear now? So what I want you need to always check out for when you are, that's what you're going to do for the other ones. So let's say when the mass is now 40 gram. So this 40 gram, just add it to this one, 235.6. When you add this to it, that will be the mass you are going to use. Do you understand? I think it's clear now. Alright, so I'm going to stop here. If you have any question, you can ask me. And if time permit me, I can still make a video talking about this manipulation only and plot a graph. So if you still don't know how to plot a graph, you can do well to check the description box. You are going to find the link to my video where I explain how to plot any graph in physics, and that will do you good. Is that okay now? So without wasting much of your time, I'd like to call it a day here. So stay tuned for number 2 and number 3, that is the optics and the electricity. Till then,